Test. All right, picking up with AWS Sense Module 7 Gas Tungsten Arc Welding. Doing this one for gas tungsten arc welding. The power source is going to be constant current. That's a CC process, constant current, which means it uses the same power source as stick welding, which is how a lot of us energize our TIG rig, right? We bite our stinger onto our TIG rig, and that gives it the electric. So we need a constant flow of electric, and flow is measured in amps, which is where we're at, okay? So this is not like MIG and flux. MIG and flux use constant voltage. They need a pressure, not a flow. All right, so there we go, constant current. And there's some sweet looking TIG welds, man. I wonder where they go to school. All right, so scratch start TIG rig setup looks like this, and we're gonna show you foot pedal style here in a second. But let's go to the scratch start first. Scratch start is king in industry. Can't carry a pedal everywhere we go, all right? So our amperage is controlled from our power source. So what I'm saying is if we had a pedal, we could set it at 100, and if we only went halfway down on the pedal, we'd get 50 amps, okay? But with scratch start, you dial it into 100, you're gonna have 100, all right? So you gotta go with it. DC electrode negative is excellent for carbon and stainless. You're going to want to know that. If I put stuff in goofy colors, you're going to want to pay attention, okay? So how do we get a scratch start to light? Well, we're going to scratch it. That's why it's called scratch start. We're going to scratch it against the base metal, and that's how it's going to light for us. Post purge, so how long? So typically we have, on our rigs, we have sizes. So a 9 is a mini, a 17 is a regular pipe rig. So a 17, and then we're going to have a couple letters, F and V. F means it's a flex head. All right, if you didn't have a flex head, it'd just be a 17. And then you got a V, which means it's got a valve on it. So wildly enough, this rig right here is just a 17. There's no, you can't tell if it's a flex head. I guess it could be. But there's no valve here, which means as soon as I turn on my flow meter, it's going to start flowing gas out. So I typically like to have a valve, a 17F flex V valve right here to shut that off. All right, and that would give me the ability to shut that gas off when I get done. And so how long should I let it post-purge? So if I'm TIG welding and I break my arc, I should hang out there for a second and let that argon cool my base metal and my tungsten. All right, cool that weld. So it's basically it's a judgment call. How long does it need to be? Long enough. Okay, so it's up to you how long it takes you. Now, if you break it too early, then you're probably going to crater crack or maybe blow some porosity. So it's just sort of a thing you get to know, I guess. So it's long enough for the puddle to cool and the tungsten to cool down as well. DC electrode positive. Oh, so polarity-wise, we want to be on that DC electrode negative. You notice that up there. That is good because it's 70% of the heat is going into the base metal. All right, so electrode negative means that we are the electricity source, and it's going into our base metal. If you reverse that, it's going to put upwards of 70%. It says 90. I think it's actually 70% of the heat onto our tungsten, which will melt it. The tungsten cannot handle that. All right. High frequency TIG rig setups are going to have a foot pedal. All right, so your AC is for high frequency on aluminum and magnesium. Typically those two base metals, you're going to want that AC. And then the high freak is going to help us do a lot of things. So keep this straight because I'm going to throw a lot at you real quick. High freak helps maintain the arc. It also helps strike that arc. Like as soon as I push the foot pedal, I can hover above, mash the foot pedal down, and it's going to jump that arc across there for me, okay? High freak initiates the arc without touching the base metal, all right? Typical purge, again, same thing, but we can actually set the purge on our machine. So that's cool. So a lot of these high freak machines will have a post-purge amount. You can set it anywhere from like 0 to 15 seconds. And it's just going to continue to flow argon until that 15 seconds is up, and then it'll stop flowing argon. Aluminum uses AC because of its cleaning action. All right, so that alternating back and forth helps clean that aluminum, and that's also good for the medium penetration of that arc. So this is a slide full of stuff. You might want to pause that and look at that. A lot of quiz questions here. All right, pulse TIG machines. The advantage of pulse TIG machines, that weld pool is easier to control, all right, because it's not as wet, as long, and it's great on stainless because it's less heat input into the base metal. Again, because the pulse increases the amps for a second and then drops it back down and lets that ripple cool before it puts the next one in. Now you got to have a special machine for this. So you're looking at those Dynasties on Millers, you're looking at the Square Wave on the Lincoln, and these are pretty pricey machines. All right, TIG rig parts. Let's look at them here. Rule of thumb, the nozzle should be 3 times larger than your electrode, and that's going to allow for that shielding gas to flow through there. But if we break your TIG rig down, and the next slide does a pretty good job, but you got nozzles, which are these pink cups, you got collets, or I call these collet bodies and then collets. And then you got your electrode and then your back cap. And these all have to be sized the same, if that makes any sense. So if you're running 332 electrode, then you have to have a 332 electrode collet and a 332 collet body. Okay, so make sure if you go to Scott Gross or something like that, that you understand that, because it's quite possible you'll buy a set that doesn't fit. All right, you might have 1/8" tungsten, 332 collets, and 532 electrode collets, and so nothing will work. Or you might buy, same thing goes with your nozzles and stuff. If you have a mini rig, a number 9 rig, but you buy 17 nozzles, it's not going to work either. So you got to make sure that everything is sized correctly. So breaking this apart, here's how she goes together. You're going to screw the collet in first, and then the nozzle on top of the collet, and then you'll slide this electrode collet in from the back. And that collet has a slit in it, and your tungsten goes in, and it'll fall right out until you put your back cap on. And your back cap forces the collet down into the collet body, and that slit is then, because it's forced down into it, that slit closes and bites onto your tungsten. That's why when you loosen your back cap, it slides out for you. Notice you have an O-ring there. You want to make sure that O-ring is in good condition so you don't leak your argon out the backside. Flow meters. All right, so we're going to, argon is the most common shield gas for TIG. Know that. It's in red. That's going to be important, right? And that's an inert gas, a noble gas. So we use argon to TIG weld. I like flow meters because it tells me, essentially it'll also tell me if I have any leaks in my rig, right? Because that little silver ball will float if anything's getting out. Typically rolling between 20 and 30, and if we're in overhead position, we'll probably want to do more, especially if we're on argon, because argon's heavy, it's going to want to come down. Now we could jump to helium, and that's heliarc welding, and that would help us float in overhead positions, but for the most part, just know you're going to turn up your gas if you're in the overhead position. So you gotta know this. So you gotta know your color codes. So TIG electrode, tungsten. So looking at this, you got a lot of colors up here, and they're used for different things. We're not going to get into that so much, but just give you an overview. For the most part, the rest of your life, you're probably going to use green, red, maybe orange. Some of us use gray, but typically you're going to stay with just a couple colors. So if you get into welding some crazy alloys, some exotics, then you're going to have to explore some more. But for right now, we're just going to give you a taste. So when we weld aluminum, we need pure tungsten. And that's going to be green colored, which means when you buy your tungsten, you're going to have a colored stripe painted on it. All right. So green is pure tungsten, and the symbol on the periodic table for tungsten is just a W. All right. So you couldn't go with T, because that's something else already. Somebody else already used it for something else. But W stands for tungsten. So this means electrode, tungsten, pure. See that? EWP, electrode, tungsten, pure. Electrode, tungsten, thoriated, 1%. All right, that's yellow. Electrode, tungsten, thoriated, 2%. That's red. Woo! And we use red a lot. Most common in the U.S. They don't use it a lot overseas. It's actually radioactive. So when you sharpen it, you should probably have gloves on, because as those filings come off on your hands, that's not good for you. Electrode tungsten zirconiated, electrode tungsten serrated, and that's the one you're going to memorize, because they're going to put that on the quiz for you maybe. Plus it's pretty common, and I remember the trick is that serrated makes me think, and it's orange, serrated makes me think of citrus, and citrus fruits like an orange is orange, so that's an easy way to memorize that. Then you've got probably some more. Lanthanated at different percentages gives you black, gold, and blue. All right, and then that gray is undefined. So the chemical symbol for tungsten is W. Good. And why do we love it? Why do we use tungsten? Why don't we use something else? Well, tungsten has a high melting point, so it can take some heat. Low electrical resistance, so it allows electricity to flow through it very, very easy, and has good heat conductivity. So we're going to use tungsten for TIG welding because it does all three of those things. Excellent for TIG welding. How do we prepare our tungsten? Depends on what we're doing with it. So if we're going to be DC electrode negative, if we're going to be welding carbon and stainless, then we want to do a tapered blunt. So we're going to pencil sharpen it, and then we're going to take it to the grinder and just nip off that edge. How much? Should be about 0.35. You can't leave it dead sharp, or it's actually going to spit. Because that's, if it's razor sharp, needle sharp right there, that very, very tip is going to get hot on you, and eventually it's going to liquefy and spit into your weld. Tungsten is very dense. If you put tungsten into your carbon weld, it's going to show up on an x-ray. So you're going to want to pencil sharpen it and then blunt the tip. Aluminum is actually rounded or balled, okay? And then how do you do that? Well, on aluminum, you could just AC and then just take off welding, and it's gonna ball up on you. Or you could flip to that no-no, the DC electrode positive, strike up pretty quick, and it'll ball it up fast for you, and then you quit and you turn it back to AC and take off. Aluminum base metals require cleaning with stainless steel wire brush to break up the oxide coating. So we threw that in on you quiz-wise because we're talking about welding and how to prepare for it. Aluminum does require a couple extra steps. You have to ball it up, and you want to clean your aluminum base metals to break up that oxide coating. Aluminum is really, really prone to cracking, so you got to have aluminum extremely clean and prepared and ready to go. Reading that, we've already done this in MIG. If you haven't seen the MIG one yet, then that's good because it's the exact same filler metal. So ER70S-2, the E stands for electrode, and it only stands for electrode when we're MIG welding with it. It stands for ER. The R is a rod for TIG welding, all right? Because the electrode in TIG welding is the tungsten, right? Because back up here we said E is the electrode. So the electrode is tungsten in TIG welding. The electrode is, on ER70S-2, the electrode is for MIG welding, but we're using it as a filler rod in TIG welding. So yes, MIG and TIG use the exact same filler metal. This is 70,000 pounds of tensile strength strong. Notice the 70, add 3 zeros, PSI, pounds per square inch. Tensile means to pull apart. And the S stands for solid. We saw that in flux core welding, there was a T there that was tubular. But MIG and TIG filler metal is solid. So no flux hidden on the inside there. You're going to have some shielding gas to get what you want. And that shielding gas for TIG is going to be inert, all right? On MIG, you can have reactive gases, like a 75-25. That CO2 in there is a reactive gas. And then the -2 is just different alloys or chemical compositions, different flavors of that. So you could have a -2, a -6, a -3, different slight variances in that. But we definitely have to make sure that our filler metal is compatible with our base metal. All right, so we can't take aluminum filler metal and weld carbon steels with it. It does not work. So you got to make sure they're matched appropriately. Speaking of which, let's talk about some wild stuff. And I'm going to glaze over this because at this we're at a basic. We will be welding some aluminum and stainless, but we don't need to get into that much detail because basically you just look them up. So what I'm saying is this is how you read carbon filler metals, right? Here you go, ER70S-2 carbon. Stainless looks a whole lot different, ER308. So that's a stainless. The numbers look, you basically look up the number for the grade and what you can use it for. And then you always grade up. So if I was welding on 308 base metal, then I could weld with 308 filler, or I'd probably weld with something higher, a 309 or a 316. I would grade up. Pulse TIG feature is great in stainless because it has less heat input. So while we're talking about stainless, just know that pulse TIG is pretty good for it. And then ER4043 is an aluminum type of filler metal. All right, some TIG characteristics. That's Big Jordan Johnson up there with his instructor shirt on, TIG welding, some stainless monsters with his camo pipeliner. Anyway, sorry. TIG characteristics. TIG, also called, GTAW, gas tungsten arc welding, is also called TIG, which actually stands for something. It stands for tungsten inert gas welding. So you probably didn't know that, but that is actually an acronym. And heliarc. Heliarc is helium arc welding. So it's, instead of using argon, you use helium, and it's called heliarc. So some small tidbits there for you. Awesome on a variety of metals. That's why we like to use TIG. You can weld aluminum with it. We can weld magnesium. We can weld chrome. So we like TIG welding. Produces no spatter and then slag-free welds. So that's cool. Less cleaning. Not very high deposition rates. Okay, so if you're looking to fill out something fast, TIG ain't it. It takes a long time. You don't have to use filler. You can just fuse, a Schedule 5 stainless. You're just going to slap them together and then just walk the cup. And that's going to be hot enough to fuse those together without using any filler metal at all. Let's label our TIG. So A is probably going to be our direction that we're traveling. Okay, so if we're walking the cup to the left there, that's the direction of weld. B is our torch or our TIG rig. C looks like we're pointing at that pink cup. All right, so that's our gas nozzle. D is pointing at that collet, the thing that's holding the electrode. All right, and so if it's holding the electrode, and then E must be pointing at the electrode. Right, that's our tungsten. A, B is our filler metal. All right, that we're introducing there. Our filler rod. Remember, AC is going to be, what are we pointing at on AC? Maybe our shielding gas. Yeah, shielding gas. And AD is going to be our arc. And then AE is going to be our weld, all right, our solidified weld. Now, if you think it's tricky to see this stuff on here, notice this is a lot bigger than it's going to be on a sheet of paper. So pay attention. Look at those arrows, because I'm not going to lie to you. It's going to be tough on that test to see what it's pointing at. But it doesn't matter. Correct answers are correct answers, or wrong answers are wrong answers. So pay attention. You might want to pause this and take a minute to look at this. But let's review. Number 1, filler metal must be the same composition as the base metal. Yes, that is true. We need to match those up. Number 2, copper-coated filler metal used for oxyacetylene welding can also be used for TIG. So we did say that TIG and MIG use the same filler metal, but we did not say that you could use TIG and brazing wire. So that's false. You cannot do that. Not going to work for you. Number 3, DC electrode negative is correct for welding mild and stainless. So on carbon steels and stainless steels, we did want to use DC electrode negative, right? Because DC electrode positive will ball our tungsten up. We don't like that. Number 4, DC electrode negative is also good for magnesium and aluminum. I'm going to go with false on that. On magnesium and aluminum, I want to use AC, alternating current. All right, number 5, ER308. ER308 is aluminum filler. No, the 308 was stainless. ER4043 is aluminum. Now that sounds right. 7, pulse current is good for stainless because of more heat input. Well, pulse current is good for stainless, but it's for less heat input. All right, so watch that one. Number 8, DC electrode positive. Most of the heat is put towards the tungsten, and that's not good. And that's a true statement right there. That's why we weld on DC electrode negative. And number 9, your post-purge should last for 30 seconds no matter what. All right, so remember way back earlier we said post-purge was a judgment call. Post-purge should last long enough for the base metal and the filler metal to cool. All right, so you want your tungsten and your base metal to cool. And that's it. Good luck on your TIG welding test.